Have you ever wondered how your phone can recognize your voice, or how Netflix knows exactly what show you want to watch next? The answer lies in something that sounds like science fiction, but is actually happening right now in your pocket. Today, I will tell you in simple words about how artificial intelligence works, and after watching this video, you'll understand exactly how these digital brains actually work. Think of AI like teaching a computer to be really good at pattern recognition. Imagine you're trying to teach a friend to recognize different dog breeds. You'd show them thousands of pictures of golden retrievers, point out their features, then show them bulldogs, poodles, and German shepherds. Eventually, your friend would start noticing the patterns and could identify breeds on their own. That's essentially what we do with AI, except instead of a friend, we're teaching a computer program, and instead of just dog breeds, we can teach it to recognize faces, understand speech, predict weather, or even write poetry. The magic happens through something called machine learning. Picture your brain as a massive network of connections. When you learn something new, your brain creates new pathways and strengthens existing ones. AI works similarly, but with math instead of biology. At its core, an AI system is built with artificial neural networks. Don't let the fancy name scare you. Think of it like a decision-making web. Each point in this web receives information, processes it, and passes along its conclusion to other points. When you feed the system data, it travels through this web, getting analyzed and refined at each step until it reaches a final answer. Here's where it gets interesting. Initially, this network makes terrible guesses. Show it a picture of a cat, and it might confidently say it's a bicycle. But here's the brilliant part. The system learns from its mistakes. Every time the AI makes a wrong guess, the network adjusts itself. It's constantly asking, what went wrong? How can I do better next time? These adjustments happen millions of times across thousands of connections, gradually improving the system's accuracy. The learning process requires enormous amounts of data. To teach an AI to recognize cats, you'd need to show it millions of cat photos from every possible angle, in different lighting conditions, various breeds, and situations. The more diverse the training data, the better the AI becomes at handling new situations it hasn't seen before. But here's something most people don't realize. AI doesn't actually understand anything the way humans do. When an AI identifies a cat in a photo, it's not thinking it is a cat. Instead, it's detecting mathematical patterns in pixel arrangements that statistically correlate with images previously labeled as cats. This is both AI's greatest strength and its biggest limitation. The strength is incredible accuracy in specific tasks. Modern AI can solve advanced mathematical equations in milliseconds, beat world champions at complex games, and translate languages in real time. The limitation is that AI at this point lacks true comprehension and common sense reasoning that comes naturally to humans. Different types of AI work in different ways. The AI in your smartphone's camera uses computer vision to identify objects and faces. It analyzes pixels, edges, shapes, and colors to make educated guesses about what it's seeing. Voice assistants use natural language processing, converting your speech into text, analyzing the meaning, and generating appropriate responses. Recommendation systems, like those used by YouTube or Spotify, work by analyzing your past behavior and comparing it to millions of other users. If people with similar viewing habits enjoyed a particular video, the algorithm suggests it to you. The training process is fascinating and resource-intensive. Imagine trying to solve a jigsaw puzzle with 1,000,000 pieces, but every time you place a piece wrong, you get feedback and adjust your strategy. That's what happens during AI training, except it's happening across multiple computers simultaneously, processing incredible amounts of information. Modern AI systems require massive computing power. Training advanced AI models can cost millions of dollars and consume enough electricity to power thousands of homes for months. This is why major tech companies invest billions in specialized computer chips and data centers. One crucial aspect people often misunderstand is that AI isn't one single technology. It's an umbrella term covering many different approaches and techniques. Some AI systems use rule-based logic, following predetermined instructions. Others use statistical analysis to find patterns in data. The most advanced systems combine multiple approaches. The recent explosion in AI capabilities comes from breakthrough techniques in deep learning. These systems use neural networks with many layers, allowing them to detect increasingly complex patterns. The deep refers to the depth of these layers, not the profundity of the AI's thoughts. What makes today's AI particularly powerful is access to unprecedented amounts of data and computing resources. Every time you interact with digital services, you're generating data that can be used to improve AI systems. Your search queries, purchase decisions, social media interactions, and even how long you watch videos all contribute to training better AI. The future promises even more sophisticated AI systems that can handle multiple types of tasks simultaneously. Imagine an AI that can see, hear, read, and respond naturally across all these modalities, much like humans do. Understanding AI isn't just about satisfying curiosity. These systems are reshaping every industry, from healthcare and education to transportation and entertainment. By grasping how AI works, you're better equipped to navigate a world increasingly influenced by these powerful tools. The next time you ask Siri a question or marvel at how accurately Google Photos organizes your pictures, you'll know there's no magic involved, just incredibly sophisticated pattern recognition powered by mathematical algorithms and enormous datasets, continuously learning and improving with each interaction. Welcome to Subscribe, and I recommend you also this video.